Good morning, everyone. This is Dr. B. Polaiah, Professor in the Department of IT, Institution of Aeronautical Engineering, Hyderabad. I'm very happy to today to discuss our topic, that is representing digital images. So this digital images, how we are representing in the sense by the help of some of the medical imaging processing applications. Okay, so what I'm writing here, along with the and medical applications and applications. This is our topic. Okay, and applications. So we are going to be see how it is represented. So actually, the spatial and gray level resolution is also important here, because though the image which we are concentrating is want to be keep in terms of digitizing. So how we may want to digitize in the sense, there we are concentrating 5 different levels of gray level, which we called as quantization has 5 different levels of gray. It means that the image formed from this signal would only have 5 different colors. It would be a black and white image, more or less, with some colors of gray. So now, if you were to make the quality of the image more better, there is one thing you can do here, which is to increase the levels or gray level resolutions up. If you increase this level to 256, it means that you have an grayscale image which is range in between 0 to 255, is nothing but 256. So which is far better than simple black and white, which we called as a gray level image. So here now you may say 256 or 5 or white wave, whatever level you choose is a called gray level. Gray level image is nothing but black and white image, black and white image. Okay. So remember that this formula will help us, which we are going to be concentrate on this formula, where it is concentrating in terms of gray level, that is G, is nothing but gray level, number of bits per pixels, that is BPP, where K is the in terms of understanding the number of levels per pixels, number of pixels. So in this case, you have the gray levels is equal to the 256, which we defined in the previous slide. And now we are also going to be concentrate on how we are calculating the number of bits, which we simply put the values in the equation. That is equation which we have to be remember L equal to 2 power of K, where L is the your number that gray levels of the total image pixel values, where K is the number of pixel values which we want to pixel. So that we are going to be keeping on to variation here. This is 256 is L and 8 bits is our K level. So hence the image would be a grayscale image, which we are going to be keeping in relation with the 256 and 8 bits. This relation will help us to understand how we are representing the digital image. So L is the normal grayscale image, which is black and white. And now this black and white image, now we are going to keep in terms of certain bits per pixel values. Then that values we are called as in terms of digitized. We want to reduce that gray levels of image. Now we will reduce the gray levels of the image to see that effect on the image, which we want to concentrate by the help of one of the image which we consider here one of the best example. Let's we say that you have an image which will be 8 bits per 8 bits per pixels, 8 bits per pixels, that has 256 different levels. Okay, so this total pixel levels are what we call as if you consider this image in terms of matrix that we call as n by m, the total values are 256 values we are representing. Okay, so here it is grayscale image, and the image looks something like this, 256 gray levels. Okay, that is what we are observing from the image, which is you are considering. And second thing is 128 gray levels, there is not much effect on an image after decrease the gray levels to its half. Let's decrease some more. In the sense, you are going to reduce the your number of levels, gray levels are decreased. So total values are 256. You are going to be reduced, nothing but decrease. How we are going to be reduce or decrease is that total the matrix value n by m value will be automatically size will be decreased. Okay, so that is important here. Okay, so coming to the that size, how we are reducing is, let you say 64 gray levels is nothing but your n by m values will become 64. What is that? 64, 8 rows and 8 columns. 8 eights are 64. So still not much effect. Then it's you want to reduce the some more levels for the sake of understanding the clarity of the image. You can also reduce. That is n by m values. We can reduce as the 32 gray levels. Okay, that is it. 32 gray levels. How we are reducing 32 gray levels? How we can reduce in terms of your what we are target, that is very clarity and resolutions, that gray levels resolutions. So here that gray levels resolutions which we are help us to understanding in terms of the representing digital images which we consider here. Two elements are required to acquire digital images. Number one, the first is a physical device that is sensitive to the energy radiated by the object to be wish to image sensor. Okay, the second called digitizer is a device for converting the output of the physical sensing device into digital form. So the digital form is here. You are going to be keep your image in terms of bits is called digitized. If you keep your grayscale image in terms of different format of the image, JPEG image, TIFF image, BMP image, etc. The color image which we are considering here, for example, you are representing digital image, not only gray levels image, but also colors image that we are keeping in the format of RGB, CMY, YIQ, etc. So that is the indexed color image, single plane that indexes a color table, that is compressed images, or right now we compared from 4 levels, gray levels to two levels, two gray levels. Okay, that is your compressed. So understanding is here. This we are concentrating not only what we called representing of digital imaging, but also we call representing in terms of applications also. Okay, so we keeping that. For example, you represent the image by example which we consider here. That is digital image representation in terms of 3-bit digitization. 3-bit digitization means the total number of bits, 1, 2, 3. 3 bits. Okay, so how many combination will become here? 2 power 3 is equal to 8. So what? How many rows will come? 1, 2, 3, 4, 5, 6, 7, 8. 8 will be coming here. 8 rows and 8 rows. You see, 1, 2, 3, 4, 5, 6, 7, 8. So 8 eights are it. This one is 8 eights. How we got this 8? So this is 8 what we are keeping K value in terms of 3-bit digitized. So we'll get that representation. So keeping here that representation in terms of color image processing, that 24-bit RGB images which we consider 24-bit color monitor actually. So this part right now we are keeping in the color models. Okay, color models. We are going to discuss in detail about color model in coming class. But point is here how we are representing a color image into RGB or RGB. Okay, so this R is sorry here reverse. I written is reverse action. So R is red, green, and blue. Okay, so RGB is one of the model which we are using in terms of color image. We call, if you suppose you want to represent image in terms of color, you have to be concentrating on the RGB color minimum. That is basic. So you are going to represent that image representation in terms of color, that is 24-bit RGB representation in terms of uncompressed process, which we are using application manager also. These are the color planes actually. One plane is this, second, third, fourth. So how the planes are graphically representation is here. Your image is in the terms of pixels in the frame buffer that we have passed across the your what we call digital to analog converters. We have different types of digital to analog converters, but here we are concentrating set analog counterparts to be fed into the screen, and then we are concentrating that DAC. DAC is digital to analog converter. That DAC we are going to be keeping on. You are getting your required expected image. Okay, expected image. Right, the image properties of the color which we are here representing here, you see by the help of some software tool I'm using here, software tool. The tool may be anything, Python, MATLAB based, or R programming based, whatever may be. But point is here, you're sending the image in terms of your representation of the digitalization form, how that values are varying from that what we call the DAC, digital to analog conversion. So it's all realistic values which we are represent in terms of your image, how it is look. Based on your variation of the properties, so we are going to be get your required image. So this is what we want to understand. We extend the your representation of the images, not only concentrating on what we call the number of pixels in the image, but we want to see the intensity of the pixel values which we want to measure. Then we are going to use histogram. So of course, it is the part of image which we are keeping in application for view towards to compressing the image or non-compressing the image is right now. You want to calculate that while you are compressing, is there any pixels of the intensity is reduced or increased, that we can understand from the histogram. So the image properties, we used to keep in terms of structure that we call small surface structure, either natural or artificial, or we may say regular or irregular. So that structure usually wood bricks or knitting patterns. Okay, and also you can say that the statistical structures analysis describes structure as a whole based specific attributes in terms of regularity, coherence, orientation, and contrast, etc. So these are we are going to be get your what we call image properties in terms of structure. So structure example, we may take that representation of image with certain application point of view, especially in application are here some what we call traffic control signal image processing. Okay, even railway department image processing also will be concentrating in different application. Okay, so coming to the here, the types of images which we are representing are, there are three types of images which we are basically or fundamentally we concentrate. Number one, that is among three, the first one is binary images. What do you mean binary? It is nothing but the zeros and ones information is called binary. But keeping that zeros and ones in terms of image formation is nothing but we consider black and white. Keeping the, for example, gray level image, which we consider black and white, that values we are going to be takes only two values, that is zero is nothing but black and one is nothing but white respectively. So the binary image consists of one bit image and bit. It takes only one binary digit to represent a pixel value. So that means OCR, that is optical character recognition, is one of the example to understand how this binary image can be shaped. So we extend this information now, OCR information in terms of threshold operation also. What do you mean threshold is here? It is a predefined value based on the knowledge of the image processing, which help us to understand that to turn the white and black value, image values in terms of pixels. That white is nothing but one and black is nothing but zero. When we consider image processing in binary image processing, there we can concentrate much more in terms of describing the characteristic features for computer processing. During pattern recognition, that's what I said. This is application pattern recognition, or in or quantitative codes actually we are using for sufficient storage during image compression. Next, for example, let me to take one example as I say that it is in continuation. Continuation, that is application point of view. We are concentrating here is applications. Okay. So let us take one problem. Object is nothing but a problem. To develop the novel dynamic model for detection of lung tumors in medical images using GA, that is genetic algorithm. So, and the second approach is particle swarm optimization algorithm. You can compare both by the help of one of the method. What do you mean to understand here? So these are the two techniques which are genetic algorithm and PSO. These two are concentrating basically the concept which we discussed in terms of binary image processing. So the binary image processing is here completely processed by the help of these two techniques, which are we are keeping in terms of process as from that is a segmentation output connected to the your proposed methods, and we may going to extract your features. Before this, we are going to concentrate your median filter for the reducing of noise, and that is a pre-image processing, and we'll get the your requirement. So there's a continuation of that. I told you that pre-image processing is concentrating, that is median filter. So when we require this type of filters, when we consider images in terms of complexity, nothing but non-linear digital filters we are going to use. So when we are removing the noise, then we are going to be concentrating understanding of sliding window partial filtering. That is comparing one pixel with another, and we are going to proceed by the use of this formula. Okay, so median filter is here, and your object function is z of s comma t. So where you are going to be casting this complete median filter will help us to compute the your original values. That means by removing the what we called noise. And I'm in the continuation of that problem which we are concentrating in novelty of the uh, image processing in terms of binary image processing by the help of proposed two methods. We are comparing based on the your one of the truth table. That is the table values we are here using. Here you are using is completely in terms of parameters and its values. Okay, parameters and its values. How these values will be changes, as I told you that thresholding value will keep in terms of the required format, and we are going to be excuse we are going to be concentrate one of the learning parameters are mu and sigma. This both will be fixed in between 0 to 1. Why 0 to 1? In the sense the values which we are going to keep towards to monitor operate for the requirement of optimization process. That is, optimization is nothing but maximizing your value. And coming to the genetic algorithm, especially how these binary image processing will be processed, here we can understand from this algorithm. Okay, algorithm. What is this algorithm proposed? It is algorithm fitness values calculations and reproduction and crossover, mutation and increment in the generation. If your output is good, then you can be continue based on your required values achievement. So there is again another type of local binary pattern, that though we are considering the concept is here binary image processing, we also concentrate that binary image processing towards to differentiate from the general simple binary with local binary pattern is here on local image patterns on different representations. It works by comparing the central pixel with its neighbor values. So, for example, you take this and comparing each and So, and the what is the meaning of comparison is here? I'm sorry. What is the use of this comparison is here? Is here the value which we are keeping, that is there any redundancy? Is there any noise we are comparing? And how many times we are going to compare? We are going to fix that values according to that pixel values and fixation of that 8 neighbor one radiation point of view. You can check. Okay. So now this what we call is continuation. I'm saying that though we are in a continuation of application. What is the application we are concentrating? The application which we are binary image processing. What is the binary image processing? It is a completely representation of digital images. Okay. So what are the parameters you want to go to be evaluated? Those are number one, sensitivity; number two, specificity; number three, accuracy; number four, peak to signal to noise ratio. That is fourth one, and fifth one is MSE. That is mean square error. By the help of these all parameters values, which we are going to calculate it and check together for the sake of all together, which one is true, which one is false, and which one is neither values in the part of tumor image, which you are saying it is in the normal region or any abnormalities are there, then we check, and those values will be given to the doctor. Then the doctor will be says to the patient whether the tumor is tumor size point of view, or tumor may be affected in terms of cancer, like that. We are going to be concentrate much more on application point of view. Let me to show that results which we are implemented by the help of a filter output. This is what we, this the image. What is this image? It is the concentration which you are keeping in terms of tumor. Based on this comparison input to output, you'll get the your required output. So you can see here the complete segmented output images we are going to be used here, and getting output also. So detecting the output in terms of your required part of the values, which where is that tumor, that part alone we can find. So it is easy to find in terms of binary image processing only. That's what I'm taking these examples. So of course, I told you that the parameters values which are we are required to calculate it in terms of with a fraction of seconds, where we can find in terms of seconds, and the output may be for the each input value, which for the based on your selected different image, you are getting output of your genetic algorithm. So next another algorithm which we are concentrating here, PSO algorithm. Similarly, the same process will be same. Your parameters you are going to be used, and according to these parameters, we are going to be prepare algorithm based on this flow chart, this flow diagram, flow chart, and we are going to be write the algorithm and execution. So with this, I'm really very happy to share my output of this information, and later we are going to discuss much more information. I'm very thankful for you all. Though it is application point of view, that's what I'm not suggest you to go any references, but suggest you to use this concept for the applications. So if you want to concentrate any more what we called application point of view, we'll concentrate in terms of biomedical image processing. Different types of images here can be processed in terms of representation of digitized value applied to the application. Thank you so much for your kind concentrations, and your very good basic lessons also. We'll continue our topics as per our syllabus in coming class also. Thank you so much. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.